Hello, in this video I'm going to talk you through variables and experimental control. A few of you find this topic quite tricky, so hopefully this will be helpful and make it super simple for you. So we need to know about variables, and variables are the things that you're investigating. They're subject to change, which is where the name comes from, and we need to know three different ones. So we need to know the independent variable, which is the one that we are manipulating. So for a researcher, it's usually we've got like two groups. So we've got one group doing one thing, and we've got one group doing another. So for example, we might have one group chewing gum and one group not chewing gum. We might have one group listening to rock music, one group listening to classical music. We might have cannabis smokers in one group and not cannabis smokers in the other one. So whatever it is that we're interested in finding out if it causes a change in behaviour, that's our IV. Our dependent variable is the one that we're measuring. So we're measuring like the impact of the impact of the IV on a behaviour. So for example, we might be interested in how chewing gum affects memory, so our DV would be memory. We might be interested in what other DVs? Stress levels, mental health, anything that you're interested in terms of behaviour would be the DV, the thing that we're measuring. And it's the effect of the cause and effect relationship. So the cause is the independent variable, the effect is the dependent variable. So we're always trying to establish a cause and effect relationship between those two. So we call that causality. Now, if we can't do that, it's usually because we've got some extraneous variables, some EV. So in science they call these control variables, but in psychology we call them extraneous variables. And they're extraneous because they're anything extra that's not the IV that could be changing the DV. So any other variables that could be affecting that DV, the thing that you're measuring, that isn't your IV. So let's have a look at some examples. So if we've got a study that's looking at the more cartoons that you watch, the more violent their behaviour will be. Well, the thing that we're measuring is their behaviour, so that's the violent behaviour, that's the DV in red. And then we're looking at the impact of cartoons. So we might have a group that watches a lot of cartoons and a group that watches not so many cartoons, or we might have a group, in fact, because it's got more in it, it'd probably be like that. Whereas a potential extraneous variable that could have an impact on violent behaviour that's got nothing to do with the IV might be something like parenting or peers, or if they are naturally that way. There could be lots of reasons why they're violent or not violent. It might be nothing to do with the cartoons. So we might not be able to establish that cause and effect relationship if we've got all these EVs. Similarly, eating junk food increases weight, so the thing that we're measuring is weight, so that's the DV, and then we're looking at the impact of junk food, so junk food being the cause for the weight. So there's lots of things again that can affect weight that could be a potential EV, like if you exercise, for example. And then the final one, though, we've got GCSE scores will have students will have better test scores after attending revision workshops. So the revision workshop, attending it or not attending it, would be the IV. So notice that there's two groups, or the junk food, having it, not having it. And then the test scores are the things that are being measured. And again, your test scores on a GCSE might be affected by other things, like what your classes were like, or whether you revised at home. So there could be lots of other reasons why you might be doing good or not doing good. And so it's important for psychologists because we need to know what these EVs are so that we can do something about them and control for them. So that's what the second half of this like PowerPoint will be about. So let's have a look at some more IVs and DVs. So memory is affected by noise levels. Well, we're measuring memory and we're saying it's affected. The cause is in the noise level, so that would be our IV, and memory our DV. Temperature having an effect on the levels of aggression, so levels of aggression being the thing that we're measuring DV. Temperature is the effect, so the cause, so that's going to be the IV. We've got men and women, so gender is going to be the IV, having an impact on your attitudes towards domestic violence, that's what's being measured. Age and reaction time, so we're measuring reaction times, that's the DV. Our age might affect it, might be the cause of the reaction times, because if we're older we might have slower reaction times, so that's our IV. And then finally, students, whether they're attentive in the morning or in the afternoon, so we're measuring how attentive they are, and then we're doing that in two groups, in the morning or in the afternoon, so they might be a little bit sleepier in the afternoon, for example. And again, all of these would have EVs, things that might affect the things that we're measuring, our DVs, that are not the IV that we're thinking is the cause. So we've got to kind of make sure we think about those so we can do something about them and control them. Now, another thing that you need to know about variables is that we need to operationalise them. We need to say how they've been measured if it's a DV, and what the groups are, how they've defined them for an IV. So it's quite easy sometimes to do this if you've got a physical thing that you're measuring, but it's quite difficult to measure psychological concepts like stress or intelligence. You might have to do some rating scales, for example, to help you measure these things, or do like a test that's been created, like an IQ test. And these are some examples of how you might operationalise variables. So if, for example, my IV was caffeine and my DV was alertness, so I'm seeing whether or not people are more or less alert with caffeine, in order to say how I define my IV, how I'd operationalise it, I might have one group that has a cup of coffee and one group that has a cup of water. So if you notice on all of these IVs, they're in two groups. So if you just think about operationalising an IV as two groups, it just makes it a bit easier. It is possible to have more than two groups, but most of the exam questions that you're going to see, they're going to probably be in two groups. And then finally, for the DV, you'll notice that for the DV, if it's something that is can be measured by like some units, so like reaction time in seconds is a unit, so that would be a good one to use for alertness. Or you could have done a ruler drop in centimetres. The mile per hour for driving speed is already an established unit, so you do something like that. But then if you've got a memory test or you're testing someone's learning, you might have to do like a test out of something, like out of 20, out of 50, out of 15 or whatever. So we'd kind of say how we'd be measuring that. And then for intelligence, you might already have an intelligence test that you could give them and they get an IQ score on that. So the average IQ score is 100, for example. So just remember, an IV operationalised just has two groups. What's one group doing? What's the other group doing? Or, you know, what the participants might be doing both groups, so what they're doing first, what they're doing second. And then the DV is what is being measured and how are they actually measuring that concept. So how are they measuring memory? They're giving them a memory test out of 20. It could be words, it could be faces, so you might like clarify that as well. Obviously these things will be in the scenario, so you don't have to make these things up until we get to the finals. There's like a final section of an exam paper where we do have to make some up, but we can come to that in a bit. And then we need to know how to control for these EVs, because we want to establish causality, cause and effect relationship between the IV and DV. We want to know what the real cause, the IV, is of behaviour, the DV. So we've got to control for these EVs and make sure they don't have an impact on what we're measuring our DV. So let's give an example. So we've got our IV's caffeine and our DV's number of words recalled, so memory. And I think I've missed off a slide or put them in the wrong, my slides are in the wrong order. So these three here might be our extraneous variables. So we might have time of day that affects the number of words recalled, and then it's nothing to do with the caffeine. Tea or coffee, because obviously that's got caffeine in, so it's nothing to do with the caffeine that we're giving them, and then the noise that they might experience might also affect the number of words recalled. So as psychologists, we need to think about how to control these, and the key thing is just make sure everyone's doing the same thing. So we have to tell them what they should do to control for it, and this is what you'd have to do in the exam question as well. So if it's time of day, suggest a time of day that you're going to do and test all people. So let's just go back to my slide. So we might say we're going to test them all at 10 AM, or 12 PM is probably a better one because that's in the middle of the day then, isn't it? So that'll get rid of any problems with time of day. We might also tell them don't have any caffeine for 12 hours before the study, because then the only caffeine that affects them is the caffeine that we're giving them as the IV. And then we might want to put them all in a quiet room, in the same quiet room, so that whatever happens, it's affecting all participants in the same way. And also if it's quiet, they might be able to concentrate a little bit better. Now, there's many different extraneous variables that could be in a scenario. So you don't have to really know the names of these, but you just need to know what could be some potential extraneous variables. So you don't need to remember participant variables, but an extraneous variable could be anything about the participant that's not the IV. So anything about them, all of these things that are on here, age, gender, mood, personality, as long as it's not the IV, because remember an EV is anything other than the IV that affects the DV. And a way to control for any participant variables is to make sure you've got a really good sample. So it's large, it's representative. If you use random sampling, that's really good. If we've got any conditions where they're only taking part in one condition, we need to randomly allocate to the conditions so that we don't end up with all the same participant type in one condition. And then we might just get our participants to do both of the conditions and compare them against themselves, which is called a repeated measures. That's usually a good way to get rid of that as well. We've also got situational extraneous variables, which are a bit trickier to kind of get your head around, but they're basically anything about the procedure that's being done. So the word list that was maybe used in a memory test, have you got the same words on there? Are they the same difficulty? Have you given them the same amount of time to do the task? You might also get demand characteristics. They might guess the aim of the study and change the behaviour, particularly if it's in a controlled artificial like setup, fake setting like a lab experiment. And then you might also get order effects. So if you've got a repeated measures design where participants do both conditions, so say they're doing caffeine and non-caffeine, then in fact that's probably not a good example, let's say we're doing a memory test and we're seeing whether music will affect your memory. We've got a classical music playing, see if that affects your memory, and then a rock music. If I get participants to do classical first and then rock, they might have had quite a lot of practice by that second condition, so they do better. Or they might just be bored or a bit tired of, like, as we call tired fatigue in psychology, so they might perform worse. So we've got order effects in that second condition. So that could be an example of a situational variable that might have an impact. Now, a way to control for most of them, particularly if they're about the procedure, is just to standardise the procedure. Make sure everything is the same for all participants. So the same time, the same word list, things like that. And then a technique for minimising the impact of order effects, I don't know why I've put that, it doesn't remove them, it just minimises the effect because they're in both conditions. So what you do is you split your participants in half, and half of them would do rock then classical, and the other half would do classical then rock. So you kind of just switch the order that they do the study. And then that means that the order effects are in both conditions and then they balance out the impact, so that the only change that you're seeing in your study is the impact of your IV and not this potential EV. Now, if you want to control for demand characteristics, a really good way is to deceive them, tell them a false aim, but obviously this then makes it unethical, so it's a bit of a problem. If we've got a questionnaire, we might put some distractor questions in, so some questions that are not really about what we're studying, but so that they throw the people off the scent of what it's about. And then we might get them to just take part in one condition so they don't know what the other condition's about, so that's called an independent measures design. So that'll stop them from guessing what it's about. And then finally, we've got things about the researcher. So it says experimental variables, but it's probably easier to think of it as research variables. So researcher bias, the psychologists might interpret the data with their own personal opinions, so they might be quite subjective and maybe not actually being objective like you would with quantitative data. So it's not very factual, it's not very true, it's not very valid. And then we've got experimental or researcher effect, which basically means the impact that that researcher has on participants. So things like their voice, their tone of voice, any kind of unconscious gestures like a frown, or they might be crossing their arms or anything like that. It might put the participants off, or it might make them feel more comfortable. Either way, it's going to have an impact. And the issue here is if it's different for different participants. If you're the same with every participant, it doesn't make so much difference because it'll affect them all equally. But if you're smiling at some and you're not smiling at others, then that's going to impact them in a different way, and then we've got an extraneous variable then, so then that's a problem. Now, a way to control for these is really simple. We can use random allocation, so we can use a simple technique of the hat. We can put all the participants' name in a hat. We can pick out half of them for our one condition, half of them for the other condition, and then that means that the researcher's not picked who goes into which condition. Also, if there's anything like a word list, we can randomise that word list so that there's not certain words on one list than the other, so that the research doesn't have any control over anything in the study. So any time that we use randomisation means that the researcher isn't picking, and then that makes it a little bit more fair, and we're not going to get that researcher bias. So let's have a little look at some exam questions that are around this topic. So the first one is saying, what's the dependent variable in an experiment investigating the effect of noise on concentration? So if it's on something, that's what's being measured. So it's concentration that's being measured. It's looking at the cause of the impact on concentration being noise, that's your IV. then number 2, what is the name of the variable being measured? So that's the dependent variable. Number 3 was a little bit tricky for a lot of people. So it's asking for the independent variable, and it says women who earn above average salaries will score significantly higher on a confidence test than women who earn below average salaries. So confidence test is the DV, the thing that's being measured. So it's not that one, so it's not C. They don't mention men at all, so it's not D. So we're left with A and we're left with B. And if we look, it doesn't talk about high or low average salaries. It talks about above average and it talks about below average. So we've got to use the word in the question. So A is the correct answer for 3. And then 4, best thing to do with extraneous variables. Well, we want to get rid of them. We don't want them to be a problem. So we don't want to ignore them, because what's the point of even knowing them if we're going to ignore them? We don't want to monitor them, because if we know that they're there, we need to do something about them. And again, we're not going to record them, because recording and monitor the same thing. So we need to eliminate them. We need to get rid of them. We need to put a control in place so that they're not a problem anymore. So the best thing to do with extraneous variable is get rid of them, eliminate them. And finally, what does control mean? Well, control means apart from the IV, keeping as many other things the same as possible. So that the only thing in your study that changes is the IV. Help people feel less lonely. We're going to a residential home, the Oaklands, an elderly residence home, and they're looking at the effect of caring for pets on elderly people. And so the dependent variable, the thing that they're measuring there is loneliness. How lonely do they feel, either before or after they've cared for a pet? And so they're looking at the impact, the effect of caring for a pet. So that's the cause of the loneliness or not being lonely. So our independent variable would be caring for pets. So you've got to put the specific caring for pets. You can't just put pets, you've got to put a little bit of detail. It's not just having the pet, it's also caring for it, so a little bit more detail. Then number 7, we've got a study here which is about investigating the difference in memory ability in young and old people. So if we have a look at the suggested extraneous variables at the bottom, it's not going to be age, because extraneous variable is anything other than the IV, and the IV is age for this one. We've got old, we've got young people, so it's not going to be that one. And our height and income do not have an impact on our memory, so it's not those. By a process of elimination, we could go, okay, maybe eyesight. But if we think about it, our eyesight is going to have an impact, because if we're giving them a word list, for example, to remember, then they might not be able to see it properly. And so that might have an impact, particularly if they're the older people. So it's worth kind of considering. So when you're thinking of extraneous variables, it's really good to pick one that actually would have an impact on the DV in a specific way that you could explain. So let's have a look at an actual written question that's come up before. So this one is about how learning might be affected by the time of day. The theory is that people will take longer to learn new things at different times of the day. So it's asking you to identify a possible extraneous variable and explain how you would control for this extraneous variable. So let's have a look at some examples. So we've got one extraneous variable that may affect the investigation is that some people may be better at learning than others, regardless of time of day. So we're saying there an extraneous variable is maybe some people are better at learning, so just like a participant variable, like they're just naturally better at learning, and it's not that IV of time of day. Or another example from the mark scheme is one extraneous variable that may affect this investigation is the participants do the experiment in different places. So depending on where they do it, that might then become an extraneous variable. So that's a situational extraneous variable. So notice that you don't have to mention situational and participant, but it helps you to kind of think of some that it might be, which is why we learned it in that way. And then explain how you would control for it. So how are you going to get rid of this as a problem? So the easiest way is to say, I'm going to standardise the procedure, make sure everybody does it the same. I'm going to give them the same reading material that they're learning about or whatever in both conditions. You could have also said you might get participants to complete both conditions and compare against themselves at different times of day, and then that'll get rid of the participant variable of somebody just being particularly better than somebody else. So you could have mentioned any of those controls that we mentioned before. Let's have a look and see if there are any other types of questions. So let's put control. So controlling extraneous variables. So we've got the scenario about watching the movie alone and with friends, and then one way that they could have control for extraneous variables. So we could control for participant variables through random allocation, so deciding who goes in the one with friends and the one that goes in alone. And let's see how they've worded it. Oh, in fact, that's just a different point. So let's see. We've got using standardisation, for example, getting both groups to watch the same movie. So the context is the movie, and then saying they do the same thing is what standardisation is. Choosing a movie no one has seen before, because that could be an extraneous variable, because if they've already seen it, then that is going to have an impact on it, because they might like it and that might make them more happier, because that's what the study's about. Making all participants watch the same movie, so that's the same as the standardisation one. Let's see if there's any other ones. That's the one that we've just talked about. And then I think that's all that they've got on control. Let's see if we've got anything on extraneous variables. About this one. So this is the one about the office, so working from home or working in the office. And it says, explain how the psychologist could use standardisation to reduce the impact of extraneous variables. So we've got an example here that task difficulty could be an issue, an extraneous variable, because if you're giving the people at home really difficult tasks and you're giving the people in the office really easy tasks, then it's not going to be anything to do with whether they're at home or in the office that they're working better. It might just be because of the type of task that they're doing. So in order to control for that, would give them the same task at home and in the office. That's the context. Otherwise, that would reduce the validity of those results. And we couldn't really say that it was our Ivy at home or the office that was affecting productivity. It might just be the type of task that they're being given. And if I was an employer and I wanted all my people to come into the office rather than work from home, I could manipulate that and say, I'm going to give all the people at home the difficult tasks and all the people in the office the easy tasks, and then I'll be like, oh, you're more productive in the office, and that makes everyone have to come into the office and not work from home. So that could be some research bias. And then maybe some people have worked at the company longer, which will affect how quickly they work. So maybe the people that have worked there longer might be more productive than the people that have worked there for only a bit of time. So it would be really good to make sure that when they are deciding who goes at home and who goes in the office, that we've got an equal number of experienced staff and an equal number of less experienced staff, so that they can compare them. So that's some good examples there. It does say in here, identification of a generic EV is not credit worthy, so you can't just put a random EV. So for example, stating temperature but not really linking it to anything to do with the scenario isn't credit worthy. But if you'd said temperature and that might affect your speed of working, then that was fine. So it's got to be something that links to what it's about, so it's got to be in context of that study. Let's see if there's any more. No, so they're all just slightly different ones. So I hope that that was helpful.